such as blog posts or conference recordings or anything about what others have done in this space at their institutions. And we thought it might be a good call topic. And so we're really lucky that we had three our presenters agree to talk with us today about their experiences. And so each one's going to aim for around 10 minutes or so. It's a lot of content to get in. So we'll see how far we get on that. Jason, if you want to go ahead and start sharing your screen, and I'll give your little introduction. I will also say, if you have a clarifying question, if you don't understand something, please feel free to chat it or go off mute and ask that question so you're not confused. We'll try to see how we're doing with time. If you have a very specific question for that speaker, we'll try to take maybe one or two between speakers, but we want to try to save some time at the end for more general questions could be asked three of the speakers. And so with that in mind, Jason's going to be our first presenter. And Jason Wells works at Bentley University as the Senior Research Computing Consultant. He was a programmer, an IT projects manager, and a mentor until a researcher asked if his STATA program could be sped up. And since then, Jason has built Bentley's research computing program from the ground up to a mature service with 62 researchers running 600,000 core hours per year of research. He is a member of the CARC steering committee for the systems facing track, has worked extensively with Exceed's campus resource integration group, featured in media segments for Exceed, served as an organizer and a panelist for the ACI REF virtual residency, and presented at numerous conferences. And he's really excited to be with us today to share about his experiences at Bentley. So Jason, take it away.
Thank you very much, Susan. That wasn't canned at all, was it? What I wanted to talk about today was just kind of the journey that Bentley has been on. We've started with this idea of craze and are moving to the cloud. So I thought that would provide a apropos image for the first image here. Sometimes this works. Just so everyone has a quick idea, Bentley is a business university 30 miles from Boston. Everything is a business topic of one degree or another, but we have undergrad through PhD programs. We are ranked somehow #1 in regional universities north for US News and are tied with Providence College. And then people should take us seriously because we have brick buildings and a clock tower, which are very important things in the world of colleges and universities, apparently. Quick timeline. So the cray that's in the upper right is the cray that I saw when I was a teenager and visited the National Cryptologic Museum in Fort Meade, Maryland, and we'll leave the rest of that sentence unsaid. But ever since then, I thought they were pretty neat and wanted to get involved with them. And so at Bentley, every year, the directors would say, hey, I've got some extra capital money. Does anyone need anything? And I would show them that picture and say, yes, we need one of those. And they'd say, why? And I never got it. But then in 2013, that researcher showed up and asked about speeding up his infrastructure, his STATA program. And just as it happened, our systems group was getting rid of their virtualization infrastructure, which was two of these things in the bottom right, the Dell M1000E servers, or M1000E collections of servers. It was funny because I knew the systems folks well enough at that time where I said, hey, can I have it? And they said yes. And no one was smart enough to say why. And at that point, someone finally did say that. And I told them, oh, I'm going to build a supercomputer. And I raised a lot of eyebrows at that point, but they let me go ahead and do it. And so we had this first generation system, which is a software MP system that honestly didn't work out very well for us until I talked with some people at the Campus Resource Integration Group that Rich was running, and got some friends at Eric Coulter to come out to Bentley and actually build our first cluster. And the first cluster was the 16 nodes in one of these M1000E enclosures. Our second generation, we actually had to retire these things though, just because of security concerns. You couldn't patch them anymore. And so I actually had to buy new servers, and that's the system that we're running on now, where it's a 600,000 core hours per year. Coincidentally, I am still the only person at Bentley University doing this. And so a lot of those questions that you saw in the email that went out, it's been really my house, getting help from people as needed when I can. And so I'm wearing every hat, from building budgets and doing strategic plans right up to creating creating encrypted disk at rest types of storage systems and rolling out the system and occasionally asking Eric for help when I can't figure something out, basically. Tracking progress has been the most important thing that I could have done, actually. You saw those 62 researchers at an institution with 277 full-time faculty. Being able to say that I've got 67 of them using my infrastructure is insane. No other group on campus has that wide dispersal. So the people, the stakeholders like my boss, folks in systems, the research council, the administration, really wanted to know what had been going on. And basically, I just started keeping this Excel spreadsheet that listed who I put on the cluster and what they were doing. And kind of, we have some larger research goals at the university. And so I put that then in there as well. But it comes in really handy just to pop up a graph like that and just show people, okay, this is the growth that we've had. The CPU hours, however, is a more technical graph where XD mod was something that we had with the open HPC infrastructure we were able to install. And that was been really nice, just being able to show the increases over time as we're going. You can see that there are times when there isn't any usage at all. There actually is, but it's just so minute that you can't really see it on this graph because of how large it goes in other months. But it's handy for showing the growth over time. So I just wanted to go through some of the different things that I've done over the times now. Department meetings and poster sessions. I'll get into this in a second, but up until 2018, I was really going to department meetings or talking to department chairs and begging them to let me talk to their researchers and asking them to please start using the cluster. Poster sessions are really good because you can look at what people are doing on their presentations and then understand from there what their computing demands are. And the ones that seem to have high computing demands, you can usually get them to start using the cluster as well. There's a website that was created that actually ended up having a huge impact on who we can get. I'll get to that in a minute too, but then kind of being able to deploy help infrastructure to your users, simply because it came in really handy because Bentley's an accounting school, and it turns out that I don't actually need to talk to people. I can just send them a help document. And because they're all accountants, they just go through the documents and get up and running, it's a very strange process, but it's highly functional for some reason. Emails and listservs so people can talk. We had this idea of actually creating our own poster session. And I haven't done that yet, but really the stories, the statements that you can get from the researchers on what they're using the cluster for are the amazing stories that you can use to get the administration to actually give you some more money for your clusters. In particular, being able to say something like, if you had a baby anywhere in the past 15 years, our researchers have had an impact on their health. The fact that monetary policy at the Fed is being set by Bentley researchers using the cluster, that ambulance fraud is being stopped. Just fundamental new mathematics progress is being made, that it's just crazy concepts that no one expects to be happening at Bentley, and yet we're doing it and we're making it happen. Research is another important element that I wanted to get people to understand. I struggle with getting the people at Bentley to understand the importance of this, but doing our own research gives back to the community. And in doing so, we learn a lot more about what we're doing than we knew beforehand. And so this panel is one example where I've just slowly been doing more and more panels, and people are getting to know me and asking me more and more what I'm doing. And this is a good example of it. But this is a paper, this is a little hack I wanted to share with everyone, but research computing at a business university was a paper that I had submitted to the PERT conference, and it was rejected by one of the reviewers. And so consequently it got rejected by everyone. But the funny thing is, you can convert that over to a paper or a poster and use it in a poster session. And then from there, you can get another use from it by putting it up on a slide and using it on something like this. And so it's really not a wasted effort. And there's concepts that I discussed in here that were completely new and that I still talk about with everybody. And there's another chart on there about the usage over time. This is the feedback loop, and it's a really important graph that I wanted to show everybody. But what's happening between 2018 and 2019 is something that I learned at the ACI Ref conference. I'll cover that in a minute, but having a research computing website and then getting somebody a research computing job title. So I introduced myself as a senior research computing consultant. In reality, I'm everything at Bentley, but that's the big one. And So whenever faculty are thinking about coming to Bentley and getting hired at Bentley, they do this search and they say like, okay, well, there's a guy with the right job title, and okay, they've got this research computing website, and look, there's details on the cluster, and all of a sudden they decide to start to coming to Bentley. 2018 is when we got all that in place. 2019 is when we hired a bunch of new faculty. Prior to 2019, this is when I had been begging people to please use the cluster. Thereafter, I've got people who are just showing up at my door asking for an account. It's a fundamental difference. And that's one of the hacks that I can give you all, is just there's this culture change that happens when you do something like that. All of a sudden, the department chairs are really proud of who they've hired. The researchers want to use HPC, and the IT directors are so confused. It was amazing how confused everybody was. They just didn't know what to do about my success. And I'm about to throw another curveball at them, which will be a lot of fun. But these are the sorts of people that we're talking about: the director of systems and data center operations, the CISO, the CIO, people like the provost and the research council. They had no idea what research computing or high performance computing was, and to a certain degree I have to explain it to some people again and again and again, because they'll probably never understand it. But those are the folks that I've really had to deploy these things like a strategic plan to. And it turns out doing that every year has been really beneficial, because it gives people updates on the progress. I think I'm going to split that into an annual report, though, honestly. But we can get that 5-year budget into those. And then the stories that I talked about earlier really helps people to understand why they may not understand HPC, that it's something that is very important. The white papers are typically more interested to people in your computer information science degrees or CS degrees, people in conferences like this or and the like, but they're kind of a way to organize your thoughts about what you're doing and why you're doing it, and try to stick to that thought of what you're doing. And then KPIs, it depends on universities. Some universities are insanely interested in these key performance indicators, but other ones may not be. At Bentley, we really are, and so I've had to kind of come up with a lot of them, and we had a session at one of the conferences one of the groups last week that talked about them, which was really handy. I wanted to have some fun with this KPI, though. I can't seem to shrink the screen. So if you look at successful external grants, you can call your sponsored research group, and I can say this statement: for FY20, Bentley researchers used research computing resources, brought in an average of $80,000 per researcher with the external grants. Those who did not use research computing resources averaged $1,000 per researcher. And this is simple math. You just need to get the list of the external grants. You figure out who's a research computing researcher, and you put them in this one, and then divide it by the number of researchers. And you take the folks that aren't in that group and put them here, and divide it by the number that aren't in that group overall. And that's how you get to make a statement like this. This is the big curveball I was telling you guys that I was going to throw at the administration, because up until now, I've been seen as a cost sink. People are kind of questioning whether or not I'm worth doing. They ask questions like, maybe we should prioritize the research based on who's doing what and the impact that it'll have. They're actually talking about returns on investments and things like that, where this all of a sudden changes the picture. With that averaging 80,000 per researcher and the number of researchers that I've got, suddenly I'm actually a person that is a cost center, a profit center on campus. I'm not a cost sink. I'm actually bringing more money into the university than they would have without me. And so that's just a different discussion now all of a sudden. It's a question of, well, maybe we should hire more researchers who use research computing. And maybe we need to kick a little bit more money Jason's way, I hope. But that's just a good way to understand what's happening at universities and expand on them. Let's see, I clicked on something. So I mentioned the cloud at the beginning. Our a CIO ago decided that we're closing down our data center. And so I've been doing a lot to look at what's happening with the data center and where I can move my cluster, and should I move to another local data center, or do I move to the cloud? I, at this point in time, believe we're moving to the cloud. It's going to be one of the commercial providers that the university has settled on, but we're looking at the price out, the cost per core hour. I want to look at deploying experimental servers fast. I've got one researcher who's just now using a GPU server. They're kind of freak things at Bentley right now, and so we haven't had to worry about it. And that would be very convenient to be able to have it only power on when the researcher needs it, and go from there. Security certifications. I mentioned setting up, tomorrow I'm going in and setting up an archive server, and part of that is doing a bunch of encrypted disks. Well, once I'm up in the cloud, the security certifications are already in place. So I've got to kind of do what I can to conform with them and make sure that they stay in place. But it just makes my job a little bit easier with not having to worry as much. Storage, however, is the big problem that you're going to find out. This chart here is not just an example. If you want to have 36 terabytes of storage, you can expect to spend about $70,000 in the cloud, and that's a nice, like cluster-based, parallel file system-based system. But you can, for 36 terabytes, you can also just go out and buy 2 hard drives for about $2,000, and you'll be all set. So storage is very expensive in the cloud. And that's just one thing to be aware of. The other thing is the hybrid solutions that are extremely attractive, but you're going to get trapped by connector and transport speeds and costs. And so really look at that. I think the fact that I can move to the cloud is probably a fairly rare example of a person who can move to the cloud. I'm not sure if universities that have petabytes of data could even consider it, for instance. I know a number of them aren't and have decided against. But in my case, it seems to work, and it might work for other emerging centers. I do, however, expect there to be a time when I have to move out of the cloud and back to physical, and it's largely going to be governed by this graph here. Right now, I'm stuck down in this territory, and it's not too important. But when I get higher up, it's going to be a problem. I don't know how I'm doing on timing, but I wanted to stick these 2 slides at the end. Conferences really got everything started for me. Bentley it's a business school, so we've got too much money. So I've been to too many conferences. So I thought I could just save people some time and say that the SC conferences that I've been to, they've just been bewildering experiences, but you'll find everything there. And so this is Eric Coulter on the CRI team, and when he came out to actually build the cluster with this hardware here and here. IEEE cluster was another big issue that I went to. I was surrounded by people who were from the very large institutes like Argonne Laboratory and the like, and they were just talking about putting devices on the chips and the RAM chips and everything else to sense voltage problems and predict when components were going to fail, which is something that I haven't had. I rely on the management software on the servers. I don't have to worry about these things. And so they really just went super technical with what they were talking about. But I did ask somebody at the end, hey, where should I be? And they told me go to the Exceed conference, which is now the PERT conference. And if you're an emerging center, I heartily recommend that everyone go to the PERT conference when you're able to. It was free this year. And I'm sure in the future, it might actually continue to be, but we'll see how COVID goes. The ACIRF virtual residency is free also. And really, for all of this, there's a guy there named Henry Neiman who runs that and runs just about everything else in the HPC world, it seems like. If you get in contact with Henry Neiman, he'll put you on everything, and you'll start ruining the day that you did that because of the number of emails that you get. But you can get in touch with everything that way as well. And then regional conferences are actually an insanely important way of making contacts with the people around you and kind of collaborating on grants and providing surplus people power if you need it, or the idea of bouncing around ideas, that sort of thing. And so in the New England region, it's really HPEC, which is in Waltham, the NARIN group, BARC, and then the Campus Champions Region 7. And then the last slide, I just wanted to talk about the communities for a little bit. You found Slack. Congratulations, you're here. But like I said, if you email Henry Neiman, you get ACIRF and the Campus Champions. ACIRF is something that Henry runs that is just training new research and education facilitators for high performance computing resources. And that's where I got a lot of the number of hacks and ideas that I've shared with you all. Campus Champions also works pretty well. EDUCAUSE research computing, and think Susan's back, so I must be losing my time. But ACIM, SIG, HPC, HPCNG, local conferences, and then the Slack groups and listservs. Cheers. That's the end.
Thanks, Jason. There are 2 specific questions to you in the chat. How about you take a look at those and see if you can handle them via chat, and we'll move on. And then if there's anything you wanted to add at the end to answer those, we'll get to it.
Sure. So Bob asked if I've considered any other usage metrics such as batch work, CPU hours. Yes, absolutely. And Honestly, the big problem at Bentley is that just getting people to understand the idea of a CPU hour has been very difficult. So I've tended to just rely on the graphs as a whole. It depends on when I start talking about more technical things, they just don't really know how to cope with it. So I have to kind of go with the big picture. When I start talking about wall hours and wait times and things of that nature, they can get some idea of the concepts, but I start to gloss over, and so I tend to just stick with that one. Always
Yeah, I
happy
think.
to hear
Yeah,
your
I think we're really trying to understand too, is as the other business school or another one.
Yeah.
We're really trying to understand, what are the trends in increasing computational use among social and business sciences, and so what are some of the other indicators that would be useful to look at? And just was wondering if you had some ideas, so we can talk offline about that. Thanks.
Which is a good example of what I was talking about. Bob is at HPS, which is minutes from Bentley, and so he and I are going to collaborate on that, I'm certain. Um, and then can you please expand on how you ended up on 36 terabytes of storage metric for the cloud storage? It was convenient. I pulled the largest hard drive I could possibly find, and then doubled it, and so that's how I just wanted to see what it would cost in order to do it up on the cloud. The 70,000 is that it's a BGFS system that's running up there. And so it's not fair to compare it to the cost of the 2 hard drives, but it just gives you an idea of the metrics that are involved here, where it's very expensive to run something in the cloud for storage. I know a lot of other institutions have thought that the cloud was a good idea until they looked at their storage costs, and all of a sudden it tanks it. You're talking about millions of dollars to store petabytes of data up in the cloud. But realistically, you need to go out and figure this out on your own. Yes, 70,000 is the yearly rate.
Great. Okay. Thanks, Jason. All right, we're going to move on to Doug next. Doug, great. So Doug Genowine is the Senior Director for Research Computing at Arizona State University. He's also served on the Campus Champions leadership team since 2016 and has chaired that group since 2020. He has supported computational and data-enabled science since 2003, when he built his first supercomputer from a collection of surplus-bound PCs. He currently architects, funds, and deploys research cyber infrastructure, including advanced networks, supercomputers, and big data archives. Doug is certified software carpentry instructor and has successfully directed cyber infrastructure projects funded by the NSF, the NIH, and the U.S. Department of Ag. So Doug, take it away.
Thank you, Susan. Are you seeing the right version of my slides? Presenter view.
I'm seeing slides.
Very good. Well, we'll keep it as is then. Thank you for the introduction. And as Susan said, my name is Doug Genowine. I'm at Arizona State these days and have been there for about 1.5 years. But before that, led the research computing group at University of South Dakota, where I worked for 21 years. So having presented about South Dakota many times, I have found that it's helpful to start with a map so people know where it is. In addition to that, I have an arrow pointing to Vermilion, South Dakota. That's where USD is located, right in the southeast corner. I'll tell you a little more about the state. South Dakota is 850,000 people strong, the fifth smallest by population, and has 6 public universities. USD is one of those. That University of South Dakota has about 10,000 students, and the med school, the only med school in the state. It is PhD granting, considered an R2 university, funded around 1862, and is trumpeted as the flagship institution of South Dakota. And it all fits in one picture there, you can see in the lower left. So let's talk about the research computing group. This is the group as it stands today, or at least as it stood in 2019, and I believe it is roughly the same today. 3 FTE, 1 director, 1 systems person, 1 applications and data person, and have had a variety of different student facilitators and education outreach coordinators part-time for the last couple years. And we'll talk more about those student positions in a little bit. But where did we start from? It didn't start with this much staff and funding. So we had humble beginnings. In 2003, a graduate student named Doug put together a Beowulf cluster of Celeron desktop PCs. So we don't hear the term Celeron and supercomputer very often, but this is what we were doing. And these computers were old then. These were purchased in 1998 because I helped install them in the computer lab. These are Gateway systems, Gateway 2000. So these were long in the tooth, even in 2003. And a friend of mine said, hey, I'm connecting these computers together to make a Beowulf. And I said, what's a Beowulf? Well, you can get extra performance. You can distribute computing across computers. Wow, this sounds amazing. And can we actually do this instead of throwing out these old Celerons? And ultimately the answer was yes. And we did this, put, I believe it's 16 500 megahertz Celerons together to run BLAST, a bioinformatics sequence alignment tool used to this day so we ran one application for one user in the USD med school. And this took a while to put together as kind of a side pet project during grad school, but we were able to actually publish this in Linux Journal in 2005, working with another student and some of the computer science department staff. So you can read our whole story there, but that's where HPC really started at USD, was as a pet project. But by doing that, we got the attention of the med school. Med schools tend to have money. And from that, we were able to get some funding through the NIH IDEA program, which is sort of like the EPSCoR program, federal program for encouraging and establishing research in states and regions traditionally underfunded in some research areas. So NIH IDEA funded a portion of the new supercomputing system that we deployed several years later, around 2006. We called that system Legacy. And you can see a picture of it there next to the coyote statue. And yes, in South Dakota, we pronounce it coyote. That's the cluster there, a couple of racks of Sun Microsystems and HP equipment. We weren't picky on hardware vendors back then. So we had a variety of equipment there. And that paved the way for a new NSF funded and NSF MRI funded system called Lawrence that we built in 2017. And that's the system on the right. Lawrence, of course, named after E.O. Lawrence of Lawrence Berkeley Lab fame and Manhattan Project fame, and also USD class of 1921 fame. So we're very proud to name it for him. So there's a closer look at the legacy system, our first proper HPC. That storage on the left is a bunch of ZFS nodes running on Sun hardware. And you can see in the middle, we have interleaved Sun Microsystems and HP 1U servers. We did that originally because the Sun systems are older, and to cool it properly, we had to have space in between because we didn't have the cooling capacity in the data center to run something that dense at the time, way back in 2005, 2006. But as we moved in and the data center developed, we were able to get better cooling density, and we used that space when we expanded and put those HP systems in there as well. So we've got kind of a mixed representation of hardware. And that interconnect on the right is gigabit Ethernet. We ran 3 different gig networks for storage, for compute, and for management. So 3 separate 1 gig networks. No high-speed fabric on this system. That would come later with Lawrence. So that system, like I said, was installed originally in 2017. I believe it has been expanded a couple of times since then. But in the neighborhood of 2,000 CPU cores, some NVIDIA GPUs, I believe these are V100s, 56 gig InfiniBand, and 10 gig Ethernet, and then 400 terabytes of ZFS. So sticking with that ZFS storage architecture. In addition to that, because bioinformatics has always been a strong use case at USD, we have these 2 1.5 terabyte large memory nodes to aid for sequence assembly and things like that. And Lawrence is still going strong to this day, and I believe Legacy is as well, though in a somewhat reduced state as nodes are aged out. But both systems are churning along. So with that success, we funded those 2 systems from an NIH grant, a State of South Dakota Board of Regents grant, an NSF MRI grant. We were starting to get our feet wet with federal funding and branched out to the US Department of Ag and applied to the rural medicine program. And we have this grant that connected USD and the med school and the nursing program to 24 rural hospitals throughout the state. South Dakota is a very rural state and has med students learning clinical practice in a rural setting, remote medicine, telemedicine, all of these things. So here we branched out to a new funding agency and were successful to fund remote distance learning system to enable research and education across the state, in specifically in nursing and medical practice. So once we had some experience across different federal agencies on our own campus, we branched out and funded a variety of different multi-campus initiatives in South Dakota. We had one about storage and a few about networking. One that's shown in the picture here. We worked with two smaller universities in the western half of the state, Black Hills State University and South Dakota School of Mines, to build out science DMZ networks, so advanced data movement research networks on both campuses to aid data movement to advanced microscopy facilities at School of Mines and a DNA sequencing core facility out at Black Hills State, as well as the one-of-a-kind underground science facility, the Sanford Underground Research Lab in the old home state gold mine in South Dakota. What we lack in population, we make up for in abandoned gold mines, and the really deep ones work really well for detecting neutrinos. And DOE and NSF have a very interesting site out there in western South Dakota. Both of these schools are involved in that effort, so the Science DMZ aided their research efforts. So now we're seeing that we can build research infrastructure not just at the campus level, but starting to look at the state level too, networking infrastructure in particular. We did this one more time in 2018, building out 100 gig on the eastern half of the state with our colleagues at South Dakota State University, who I see are on the call today. Hello, Kevin. This was a great opportunity to work with the Board of Regents and the State Research Network to get 100 gig on the eastern half of the state. And as I understand it, after I departed USD, the western half has been wired up as well. So now we've funded infrastructure computing, data, network, distance learning across the state. What about our regional partners and neighbors? What can we do there? So at the beginning of 2019, we partnered through the Great Plains Network, our regional network provider, comprising 6 states to build the Great Plains Regional Cyber Team. So now we're funding people, now we're funding facilitation and mentoring. And this effort continues to this day. In fact, I think Kevin Brandt from South Dakota State, who is on the call, is actually leading this effort, or at least heavily involved. And it is great to see that continue. This effort paired mentors from lead institutions or larger institutions in Missouri, Oklahoma, and other places with mentee, that is learner institutions in South Dakota, Nebraska, and other places in the region. This was a great experience. This was one of my very last experiences at South Dakota was hosting a mentor engagement from this team at USD in late 2019. And it also continues to this day, spreading research, facilitation, awareness, and training, data carpentry, software carpentry workshops, and lots of people and researcher-facing efforts. So really spreading our wings beyond just equipment now and funding the people side of it. So speaking of people, we got a GA position. We actually had staff in 2017. We had a variety of students work for us over the years. Starting in the left, we've got Adam and Wendy, and then Joe and Addison in the lower right. And then in 2019, hired a full-time staff for application and data-facing efforts. That's Bill in the lower left. So that's where those FTE come from the beginning of the talk. And what we really needed to fund with this was researcher-facing efforts, right? We'd gotten pretty good at building infrastructure, building hardware, but telling people about it, building awareness, just fighting that awareness battle first was the biggest challenge. And the students really rose to the occasion because they were all in different departments. So Joe was in biology and Adam was in chemistry, and Addison was in computer science. So we were able to build awareness from the ground up and then bring them to software carpentry, bring them to data carpentry, and build that literacy next. In 2016, we started our first training workshops. These were kind of tailored after software carpentry, though they were not officially sanctioned, at least not yet. But we had good uptake on that, and were able to, I believe in 2018, host our first data carpentry workshop up in Sioux Falls with participants from around the state, from around different institutions, put on in partnership with the NSF Big Data Hub. So now we've got, again, we started with that campus level facilitation and human facing effort, and now reaching out to the entire state. And lastly, outreach for children, build that pipeline, right? Partnering with the South Dakota Governor's Camp for Gifted Children, targeting middle school and high school kids, teaching them about distributed computing through playing cards and building a puzzle together on different tables, and building a Raspberry Pi cluster. That's my daughter helping out there with the, we called that little cluster Larry. Larry is little Lawrence, and Larry is running Twitter API on a tile display, and tile display meaning a bunch of old gateway monitors that we hooked together to show students distributed computing, distributed rendering of that Twitter API. So finally reaching all the way from humble beginnings from Celerons to K-12 education. That was the research computing group at South Dakota, still going strong to this day.
Thanks, Doug. We're going to move on in the interest of time to Lauren. And as I said, we'll have a Q&A with what remaining time we have. So Lauren, if you want to get your screen started. Lauren Michael has worked as a research computing facilitator at UW-Madison Center for High Throughput Computing for 8 years and leads research facilitation at UW-Madison and for the Open Science Grid. She serves as co-PI and lead of facilitation services for the NSF's new partnership to advance throughput computing, and previously served as lead ACI ref on the ACI ref project. You probably recognize her as co-coordinator for the People Network, among other relevant roles to CARC. So Lauren, whenever you're ready.
Yes, and I realize that's the description I gave you for February. I've stepped back from my role as People Network coordinator, as I think most of you know, and Bob stepped in. Thank you, Bob. So I came to UW-Madison in the organization that I still work for today in 2013. And there were some big things happening on campus around research computing in a couple of years before that, including plans for the creation and hire of my position, which has grown, as you might tell from Susan's introduction. But I'm going to talk about, even though I'm from a large campus that is well-resourced, how our research computing center really emerged at the time of my hire. And that in some ways our campus is still working on and is still emerging with a centralized research computing strategy. And to just sort of walk through some of the steps there. My perspective will be, of course, bent toward the core research computing center that I work for, and also toward what we've done with research computing facilitation, but I'll touch on some other things too. So there, and I've linked to reports at the bottoms of these pages that you could go reference if you wanted to, but in 2011, the campus IT committee, which at the time was sort of the committee of faculty and IT leaders, and some representatives from the Vice Chancellor's Office for Research, was really sort of tasked with overseeing and advising IT investments on campus. And the report that year had identified that research computing was sort of the #1 issue that really needed centralized focus. At the time, there were multiple research computing facilities that served different subsets of the campus community. We're a large campus, highly distributed, not just administratively, but in terms of power and autonomy as well. And so with the 40,000 undergraduates, 10,000 grad students, around 2,000 faculty and 20,000 staff, these are organized in multiple colleges. Each of those have multiple departments and other types of centers or schools. We have centers and institutes for research, as you might imagine, some of them part of colleges, some of them not. And various combinations, even spanning colleges, but not wholly representing both, have existed for some time. And with many faculty left unserved by some of these organizations who were running some of their own clusters. And beyond sort of that general state of things, with no core research computing center or centralized governance or vision, the IT committee executed a couple of campus-wide events for researchers to look at what computational research was being done, what needs were not being met, and identified some really core priorities that the human side of research computing and data services was really not well executed across these distributed and sort of disparate service providers. That there really needed to be some work around campus cohesion while still honoring some of the autonomy that's necessary. And then there were priorities mentioned or determined that there really wasn't good storage options or weren't good storage options for researchers. A lot of people were working with hard drives if their department didn't offer some sort of storage option, and most didn't. But the campus was well on its way with network, which was a priority identified, but certainly since this time, UW has, because of private and public partnerships of galore, really excelled in its backbone network. We also had a new CIO coming on at that time who had a strong research computing background and interest. And so that IT committee commissioned a subcommittee that basically recommended in their report that there needed to be a research computing initiative that ended up being called the Advanced Computing Initiative, or ACI. And it made several very specific recommendations. One, CHTC, which was already established in the Department of Computer Sciences and had contributed to sort of worldwide use technologies in distributed computing, had been running a computing pool for a large set of researchers that had happened to come to them, was the best candidate for serving as the core center and needed some additional investment to amplify and escalate the services it provided. Those service priorities included more coordinated resource sharing amongst other providers of computing across campus, where CHTC could play a coordinating role, centralized HPC, which really didn't exist. Even if CHTC already had an existing pool, it was much more for high throughput computing, nothing, MPI based, for example. That the campus needed to figure out what to do about cloud, what to do with large data sets and visualization, that there were almost no services for those latter two, even in existing providers of research computing. And then they also identified that there needed to be a central view of researcher-facing human support. And that's where the sort of design for research computing facilitation grew out of, with an eye toward increasing engagement with life sciences, social sciences, and humanities. And another major recommendation was that there really needed to be a research computing office that made decisions about which entities on campus, not just CHTC as the core research computing center, needed investment to cover a variety of services and to coordinate research computing facilitation across campus. And what emerged out of that as what was meant to be a stepping stone to that office was an ACI faculty director and then faculty committee to do some of that initial advising as to where certain expenditures should go. And that included also a central website that exists today, aci.west.edu, centralized service listing, including CHTC, but these other service providers on campus, particularly other resources for data management in the libraries or through central IT, and then also events, outreach, and training. And that central IT's role would be primarily in fundamental infrastructure. And a good image from that particular report, I think, demonstrates that sort of central IT, CIO, COO, and DoIT as our central IT organization would focus much more heavily on backbone infrastructure, while the research computing officer would think from sort of the research side into that infrastructure. So here's what happened. CHTC was already sort of playing a role in coordinating with other clusters on campus. Many of these use Condor, which is technology that CHTC has produced its job scheduling, but it works without a shared file system, transferring files, and allows different clusters to share resources with each other by using those transfer mechanisms to move computing and data between systems. And so we've really got a campus grid, and then CHTC is sort of the core provider, and at that time had non-InfiniBand, but very large pool of compute capacity that could also then send jobs out to the open science grid, again through Condor. And that was part of how we had already accomplished resource sharing, but basically strengthened some of those relationships. We implemented this idea of research computing facilitation, which was fueled by past experiences of our CIO, past experiences of our CHTC staff in supporting researchers on their computing system as it became the core system, but with some flavors that I, in my hiring as the first research computing facilitator, got to sort of inform. We, to this day, meet with every new researcher who is interested in research computing capabilities, regardless of whether they contact us and end up using CHTC or not. So our facilitator team was sort of the campus facilitator team, and to this day still is, in collaboration with other units that have facilitators, to point them to the best services, whether it's the ones that we sit most closely to or somebody else is on campus or off campus. And the other thing that I think really stands out is our teach to fish approach. So rather than doing work for researchers, we do things like never touch their submit files for them, walk them through troubleshooting processes rather than just doing that and telling them what the fix is, those sorts of things. And then another thing that sort of stood out, even compared to how other campuses had been doing support for researchers, was that we decided that facilitators should be designated, dedicated, and deliberate. So rather than distributing the work of supporting users across a team of what in the past in CHTC had been technical staff, Condor developers, systems administrators, I was sort of a hire in somebody who would be the designated face or the sort of the human interface for users. We also got several sort of one-time injections of funding as a result of that faculty committee's recommendations. So we were able to add support for high memory compute, big data, and that was across both our main pool and a sort of standalone cluster backfilled by that pool just for MPI computations. And that's what we call to this day our HPC cluster versus our larger HTC system. So we got about 8,000 cores of additions between donations and some money that the campus needed to spend before the state took it away to add some significant amounts of computing. And I don't know that we'll ever see the scale of this type of investment again. The impact of facilitators, especially in this space, was really sort of apparent. I was hired in January 2013. So I've started here with data from the fiscal year that ran into that time frame. And then we had a second facilitator, Christina Cook, if some of you know her, in late 2014. And in just that 2-year span from prior to CHTC being the core research computing center to adding HPC capacity, at least initially, and facilitators, we really increased the amount of usage of CHTC resources, but also by key communities like life sciences and social sciences, with some initial uptake from the humanities, because we also had a digital humanities thing going on. Importantly, because we could approach researchers with different types of infrastructure optimized for different modes of computing, we found that high throughput computing was really critical for engaging the life sciences and social sciences. And it was also for humanities. Basically all of our usage from humanities, although it's too small to show up here, was high throughput computing. Even when, because we met with people, we could orient them not just to what would be right for them, but they had options to access. And so most of that new usage was on our high throughput computing system, even though we had also added significant capacity for HPC. And that was even true for the more traditional users of large scale computing, who many of whom, especially in engineering, came to our core computing capacity, even for the HPC cluster, away from having to operate their own clusters, because that community was definitely running a lot of their own clusters on a per research group basis. We've sort of documented and publicized our particular model of research computing facilitators, heavily informed and influenced by our interactions through the ACIRF project that Susan mentioned in my introduction, and that many of you may be aware of, which is what led to CARC thinking beyond the scope of facilitators to what's necessary to improve networking between professionals of all types in research computing and data. But you can read more about our particular model if you'd like. And to this day, we are, as a center and our facilitation services, really an important part of the research computing ecosystem on campus. But I'll wrap up in just a minute with where I think we are now and where some of the things that we haven't invested in well as a campus are yet to come. I won't go into too much detail here, but just as sort of another snapshot, and I'm showing 2019 data partially because 2020 for many of us was kind of weird. But we do significant engagement with researchers in terms of consultations and office hours. We've seen really significant continued growth from the life sciences, like I think many campuses have. And this is just on our own hardware, not necessarily across the entire UW grid, or including our campus usage of the open science grid, which is significant, adding up to that 360 million hours on the last slide. And this is the picture that we can present to users to this day. CHTC supports many sets of, or many types of compute modes. We've invested in specialized hardware for GPUs in addition to high memory. Those have also been injections that we've pursued. But our pool delivers hundreds of thousands of hours per day, and individual users regularly exceed 10,000 hours per day. But we're also part of this bigger campus grid and ecosystem. Condor has built-in tools that allow users to send their jobs to the open science grid, to other pools on campus, to the cloud, or to all of these at once, which is really awesome. Our HPC cluster, after those major additions in 2014, hasn't had any significant additions other than researcher purchases that have been added on. And so here's where we kind of are today. CHCC, I think the campus succeeded in establishing a core research computing center. It was nice that CHTC already existed among others on campus who had experience with research computing and was able to work with those organizations. Some of this I did myself to encourage resource sharing. And so we checked a lot of boxes from those priorities that I mentioned earlier in the 2011, 2012 timeframe. But we've had a net hardware capacity loss because things have died and we haven't had any refresh. Part of that is because the campus's centralized governance and advising around research computing has gone through some reorganizations and has faltered in a couple of ways. So that ACI initiative kind of fizzled partially because its governance and advisory role from that faculty committee ended up being moved into RTAG, or our Research Technology Advisory Group, which is one of several technology advisory groups on campus. We've had change out of leadership in our Vice Chancellor's office and CIO. And while we've had persistent funding for RCFs, which has led to other hires of research computing facilitators across campus in different units, data science facilitators associated with our data science hub and institute, which have been really big investments with private partnerships. We still are relying on, as a campus, organizations like CHTC and even others having to constantly advocate for one-time injections to keep up the services that we've added as a campus. And Central IT has really stepped up, I think, in the storage space. They also helped with cloud procurement, which has helped researchers be able to access cloud more directly when not appropriate through CHTC. But some of these things still come with a cost, and there isn't really sort of a centralized vision for visualization still. So that's kind of where we are. And with that, I'll take questions and look forward to the rest of the time we have to discuss.
Great, thanks, Lauren. I know we're close on time. We knew we would be, but just open up if anybody's dying to ask a question. Please do so now. I haven't seen anything come through the chat.
Yeah, there were some questions for Jason earlier, at least one. And maybe he had a chance to answer that.
Yeah, Jason, I think, did you get to your questions? I know there's always, welcome questions on the CARC Slack or through the listserv, or you can reach out directly to any of our presenters today, of course.
Claire's question almost seems to hit at one of the issues that I've got at Bentley as an emerging center, which is how many staff are you supporting? You'll notice in the entire presentation I used we. It's me, it's just me. But I suspect that's something that we all are guilty of doing, but just thought I'd point that out.
Rich, I see that your mouth's moving, but we can't hear you.
I have the double mute problem. Thanks for the check, Lauren. Thanks to all of our panel, and thanks especially to Susan Ivey for moderating. We'll be back next month to talk about new resources through the NSF Track 2 program, Jetstream 2, Bridges 2, and Anvil at Purdue, and that rhymes really well. Thanks everyone. If you have follow-up questions, don't be afraid to reach out on Slack or on the EC mailing list, and we'll see you next month.
Thank you.
Thank you.